Kia ora gentlemen, and welcome back to another interesting, thought-provoking and challenging episode of Atomic Structure Part 2. Today we're going to delve into some equations. Now this is a bit different to my other videos, it's a bit more hands-on, so I hope the multiple displays is not putting you off. But we'll see how it goes, give me some feedback, and we'll see if you can learn through this way. So, reactions. I'm going to go over what we've done in class for those that weren't there, and to just go through the MASH and Corsac reactions one more time, giving you a bit of practice as we go. So, we've got to remember, all reactions, chemical reactions, have reactants, and that's the things that go into our reaction, okay, and they produce products, these things here, okay. Now our MASH reactions, remember each letter of MASH, M-A-S-H, stands for something. Okay, so right now all of you should be saying, Sir, M stands for metal. Okay, plus A, which is an acid, alright, makes a salt plus a hydrogen. So whenever you're looking at an equation, and often you're only given this bit here, okay, the reactants, you'll see a metal, could be magnesium, could be zinc, could be sodium, could be iron, could be any of those. You also will see an acid, one of the three ones we use in the lab, hydrochloric acid, so nitric acid and sulfuric acid. So it could be one of those three, alright? Now, that will trigger you, hopefully, not in anger, but to be able to make this salt and to know that the gas, the fizzing that is given off, is hydrogen. So let's walk through an example. Magnesium, one we've done in class, really simple, okay, and we're going to mix this with some hydrochloric acid. Alright, I'm just going to move the table ions down a little bit for later, and this is going to make, got some of the borders giving me a bit of an audience here, give them a shout out. Magnesium plus hydrochloric acid is going to make two things, it's going to make salt and hydrogen. So we can automatically put our hydrogen here, because we know what that is, alright? But the difference, okay, here, is where does the magnesium and the chloride go? Well, the magnesium, being more reactive, will want to bind with the chlorine. So we get this substance called magnesium chloride. Okay, magnesium chloride plus our hydrogen over there. Alright, magnesium chloride plus our hydrogen. So just spaces it out a bit better so you guys can see them. Hydrochloric acid plus magnesium chloride. Alright. Now, at year 9, that might be okay. That might be enough to get you a good pass grade, alright? But now we need to balance it. And this is where a few of you need to do a bit of practice, okay? And that's where this table of ions comes in, alright? You've all been given one, and you need to know how to use it. You will have one in every assessment you do, so it's good to learn to use it, alright? Now, the first thing we've got to do is look at each individual compound or element and check if they're balanced. If they're by themselves, typically the metals, they are, we don't need to do anything in terms of putting little numbers or big numbers at them at this stage. So this magnesium is okay by itself, alright? However, our hydrogen likes to live a bit differently. Hydrogen likes to live with another hydrogen bound to it. So we often see hydrogen as H2. Okay, so if you can just remember that, that will help you balance the equation a bit easier. Now, going through this, magnesium by itself, if we look on our periodic table, table of ions, it has magnesium 2+. Okay, we'll move on to hydrochloric acid, a hydrogen and chlorine. Okay, so if we look at our hydrogen, where are we here? Okay, our hydrogen is a positive ion. Our chlorine is on the other side as a negative. Hydrogen plus chlorine, okay, a positive plus a negative, they cancel each other out. We don't need to do anything to sort this one out. Okay, so hydrochloric acid. Alright, moving across, magnesium. Now remember I told you what this one was over here. Magnesium can be found in the second column. Magnesium has 2 plus charge. Okay, it has two electrons that it wants to get rid of, and it will become a bit more positive because of its protons. So, where's it going to find those? Well, we've only got chlorine and hydrogen. Hydrogen's a positive ion, so it can't be that. So it's going to have to get them from chlorine. Now, chlorine here only wants 1 extra electron. So magnesium's giving off 2, but it only wants 1. So magnesium is going to have to find another chlorine. So if we've got our 2 plus charge at the top here, and our -1 here, we will need 2 lots of chlorine before we can balance out the 2 plus of magnesium. So the swap and drop method, guys, if we've got the 2 plus up here, we just simply put the 2 down here. If this is 1, we put it down here, and because we're chemists, we don't write down ones, okay, because we're efficient. Others might call us lazy, but we're efficient, alright? So magnesium chloride, and that is now balanced as a compound, alright? Now we're going to look at the whole picture. So that's what I call balancing small, because we use small numbers, and we've added these 2 numbers here. But we need to add something else, because if we look at it and we count, we're going to find that we are not equal. Okay? What do I mean by that? Well, we check what goes in. Okay? And it's often handy to draw a little table. So magnesium here and magnesium here. Okay? 1, 1. 1 going in, 1 in the reactants, 1 coming out as a product. That means magnesium is fine. Okay? Hydrochloric acid. Let's have a look at this one. We've got 1 hydrogen here. We've got 2 over here. That looks like it's a bit of a problem. Okay? Let's just double check the chlorines before we panic and do anything to the whole equation. We've got chlorine here. We've got 2 there. Right. So, magnesium is okay. We don't need to do anything else. Hydrogen and chlorine, we've got double the amount coming out over here. So if we've got double the amount coming out as products, what do we have to do here? Well, we're going to have to make double the amount this side. Now, boys, you often get caught out because you think, I've been doing all the little numbers, I'll put the little numbers in here. You've got to know this, if you put the little numbers either side of this, so H2Cl2, that's a completely different compound. If I was to draw that, hydrogens would be bonded with chlorines and there'd be lots of different things. You'd have 4 atoms all bound together. That's not what's happening here. We want 2 hydrochloric acids, not H2Cl2. I don't even know what that'd be. Dihydrogen dichloride or something. So we need to get double the amount of this molecule here, not change it. So how do we do that? Well, I just said before we're balancing the whole equation. We're balancing big. If we're balancing big, we're going to use big numbers. That would make sense, eh? So if we're going to balance big, we could add, I'm running out of space here, I didn't think this through, we're going to add a 2 here. Okay? 2 lots of hydrochloric acid. If we've got 2 lots of hydrochloric acid, now we've got 2 hydrogens and we've got 2 chlorines. So let's see if that works. 1 magnesium going in as a reactant, 1 magnesium coming out as a product. 2 hydrogens going in as reactants, 2 hydrogens coming out as products. 2 chlorines going in, 2 chlorines coming out. Looks pretty good to me. We are now balanced. That is our mass reactions. As a challenge to yourself, I think I could challenge you by saying sub out the magnesium and try it with sodium. Get rid of all the numbers and start again. Okay? You might find that the sodium does exactly the same as a metal, as the magnesium, and will kick out the hydrogen just as easily as chlorine. That starts you off there. You could give it a go with zinc, and if you really want to challenge yourself, you've got a iron here in 2 forms. Give it a go at using hydrochloric acid to balance your iron in this reaction. Iron 2 with hydrochloric acid and iron 3 plus with hydrochloric acid. Give those a go. Okay, so there's some challenges for you. If you've already done those, you're doing well. Make sure I check them in class next time you have me. Alright, hope that made a bit of sense. I hope this format isn't too confusing. I'll see you soon with more core sac reactions. Do some study, get those pages done.